All right, everyone. So good evening, and let's start the session. And I tell you one thing, everyone. So today, means on Monday, there will be no session, and the entire information will I'll just update on the WhatsApp group. On Monday, there will be no session, and then since from the next week we are going to segregate our ML and AI candidate, so we'll have the classes accordingly. And today, the last common topic we are going to discuss, and it is the knife base. Okay, in the supervised learning, we are going to discuss the last, the the common topic. And if you will just explore the syllabus, then actually in the AI, the module from 4 to 11, whatever your module was having, it was actually the common with the ML. I'm not talking about the basic concepts. I'm talking about the specific ML concepts, especially in case of supervised and supervised learning, as well as I'm talking about the data cleansing and all. If you remember, in the starting, I had discussed about the this PDM and all the data cleansing and all. So that was the common, but I have not looked into it because some of you has I don't remember her name. I think Khushbu was there. She has asked in the WhatsApp that only ML concept is getting covered. So because 4 to 11 module that you had in your syllabus, it was just ML. Yeah, so I had to cover them, and that's why this group was combined. Now, from the Monday onwards, your group will be segregated, and the information will be posted in the WhatsApp. Okay, everyone? So let's see the night base, which is the also supervised machine learning algorithm. Yeah. And before that, we had worked yesterday on the decision tree. So if you have any questions, then you can discuss. Otherwise, let's start this night base. Okay. So anyone, what is night base classifier? Do you know about it? Although it's a very short algorithm, but still it is very useful if you're working on the NLP problems. Then for the NLP problem, when although NLP problem by its base, it's unsupervised learning, but when you used to implement it in the supervised case, then night base is one of the best effective model that we use in this supervised learning in case of doing prediction of the text data. Particularly, I'm talking about the NLP data. This is really very, very, very useful. Although since it belongs to classification, so you have n number of classification model. Friends, I'm audible. I have connected my earphone.
Yes, sir.
Okay. So that's why it is really very important. Okay. And when it connects to the night-based algorithm, so let me share my screen. Yeah. So let's talk about this naive base. And I was saying that it's a supervised learning, first thing. So it's a what? It's a supervised learning. Means obviously if you have to use it, then there must be a while. There must be a output variable for it. And this naive base that I'm talking about, it is actually based on the Bayes theorem. It is based on the Bayes theorem, and that is used for classification problem. Yeah. So if anybody talks about the particular use case of this model or this algorithm, then I can say that this naive base is used for text classification. Yeah, even for example, suppose any post is viral on the Facebook or any text data you have, and you just want to predict that whether it's a hate speech or not. It's a hate speech or not. So in that case, you can use this naive base. Okay. So here, whenever we have to build a quick prediction, then in terms of the speed, another thing I can tell you that this naive base is basically a very fast machine learning model whenever you have to build any algorithm. All right, so you know, okay, somebody's got. Search. Okay, now if I have to again characterize this naive base, then I can say that this naive base is what? It's a probabilistic classifier. Okay, so when I'm saying that it's a probabilistic classifier, that means it will be predicting on the basis of the probability of an object. And if I talk about the some of the use case of this naive base, then I tell you that we can use this naive base in terms of if you have to do spam filtration, that whether it's a spam or ham, or you can use it for the sentiment analysis, or you can use it for, say, the classifying any article. Now the question arises, why this naive base is called as naive base? So basically this naive base is built up of two words. One is called as naive, another is called as base. When we are saying that it's naive, because it assumes that the occurrence of certain feature is independent of the occurrence of the another feature. Yeah, although I tell you that in this supervised all are the naive, because this is the basic concept that we used to consider in case of supervised algorithm, that your data should not be dependent to each other. Yeah, your data should not be dependent to each other. They are independent to each other. So here, this is called as naive because the occurrence of the certain feature is independent of the occurrence of the other feature. For example, if I tell you that any fruit is there, so that fruit will be identified on the basis of its color. It will be identified on the basis of its shape and the taste. Yeah. So color, shape, and taste, on the basis of that, this fruit is going to be identified that whether the fruit is apple or the orange or the lychee, banana, whatever is there. So when I'm saying that this is naive, it means that here the existence of shape is not because of the existence of the color, or the existence of taste is not because of the existence of the shape. Okay. Yeah. So that means this is they are independent to each other. Okay. Now, when I'm saying about this Bayesian classifier, so it is called as Bayesian classifier because it follows the Bayes theorem. And when I'm talking about the Bayes theorem, then this Bayes theorem says that if you want to determine the probability of occurrence of A, if you want to determine the probability of occurrence of A when B has already occurred, then it will be determined through the probability of B over A. That means the probability of what is the probability of B when A has already occurred into the probability of A upon probability of B. Yeah. So this is the conditional probability. Okay. This is the conditional probability where the probability of occurrence of B, you are just trying to determine the probability of occurrence of A over B. Over B means when B has already occurred, it will be determined through the probability of occurrence of B when A has already occurred into the probability of A upon probability of B. Okay. Now, let me explain this. So, do we have, let me check. Yeah. Suppose we have this data. Okay. We have this data. All right. Where we have two variable. One is outlook, another is play. Okay. We have these two variable. One, the outlook, another is play. Yeah. And the question is that when, what if when the weather is sunny, then the match will be played or not? If the weather is sunny, then match will be played or not. This is the problem. Okay. So what if I give input as sunny, then what is your prediction? Whether the match will be played or not. So whenever we have to do this, then what we do, we just do this in the three step. So what is the first step? In the first step, we just get the frequency table. In the first step, we just get the frequency table, means whatever data we have given, we'll just get the frequency table of it. And then on the basis of this frequency table, we'll be creating the likelihood table. We'll be creating the likelihood table of each data. And once it is done, then we are going to apply the Bayes theorem. Then we'll be applying this Bayes theorem. I hope you understand, everyone. Now, so here I have already told you that the problem is when you give the value of sunny, that when the weather is sunny, when the outlet is sunny, then what is your prediction? Whether the match will be played or not. So let me do according to that. So first of all, what I'll do, I'll just create the frequency table. Okay. I'll just create the frequency table. So in this frequency table, what will be there? So guys, if I talk about this, then you know in this outlook, we have what? We have different weather. And we have what? The yes and no. So anyone, alphabetically, how many unique variables are there? How many unique data is there? So that is, one is overcast, isn't? Another is O, then R, that is rainy, and then sunny. Let's count the frequency of yes and no of these. So overcast has occurred for, let's talk about this yes. So 1, 2, 3, 4, and 5. Overcast has occurred for 5 times. And what about the no? So there's no any overcast in terms of no. In the rainy, 1, 2, 2 is rainy, and if I no, then 1, 2. 2 for no, sunny, 1, 2, 3, and this is 2. Okay. Now if I count here, so it will become total yes is 10. Total yes is 10 and total no is 4. Isn't everyone? So the total yes is what? No, 10, and the total no is 4. So this is what? This is my frequency table. Now I'll be calculating the likelihood table. So I tell you that although in the likelihood table we try to get the probability of each, but here if I talk about this one, okay. First of all, please tell me what is the probability of yes? What is the probability of yes? The total is
10 by 14.
10 by 14 because the probability is determined how? The number of interested event upon total event. So I'm interested in the yes, and the total is what? Yes plus no. So 10 upon 14. And what is the value? Anyone please calculate?
Zero 0.7142.
0.71. Okay. 0.714, huh? Okay. Now, what is the probability of no? So that will be 4 upon 14. What is the answer?
0.28.
0.28.
0.28. Okay. So this is the probability of yes and no. Now, if I talk about the probability of weather, so what is the probability of overcast? So the total overcast is what? 5. And what is the total weather? 14. So 5 upon 14. What is the value?
0.35.
0.35. Okay. And what is the probability of rainy? So you see that the total rainy is 2 plus 2, 4. So 4 upon 14. And it will become 0.28. Now, if I talk about the probability of sunny, so it is 5 upon 14. What is the answer?
0.35.
0.35. Okay. Now, my question was, what is the probability of play over sunny? This was there, no? So if somewhere I just find out the probability of yes over sunny and probability of no over sunny, and whichever will have the higher proportion, that will be the result. So let me find out what is the probability of yes, means what is the probability of probability that match will be played when the weather is sunny. So what will be the formula of it? It will be the probability of sunny over yes upon the probability of yes upon probability of sunny, isn't? In the same way, if I talk about what is the probability of no if the weather is sunny, so how can I calculate again? So that will be the probability of no over sunny will be determined on the basis of probability of sunny over no into probability of no upon probability of sunny. Isn't everyone? So here we know the probability of sunny. Now if I talk that what are the different values we know. So we know this probability of sunny here, that is, isn't? We know the probability of no. We know the probability of yes. What we don't know? We don't know what is the probability of sunny over yes and what is the probability of sunny over no. Okay. So how many total yes are there? How many total yes are there?
10.
10. Out of 10, how many times weather was sunny?
3.
3. So if I talk about this, that when the match was already played, what is the probability of sunny what is the probability if I say this one? Now I'll just delete this data. Okay. Now if I say this, what is the meaning of this? Then I will say that what is the probability of sunny when match was played? So match was played means yes. So what is the total value of yes? 10. Out of that, how many times match was played when the sunny was there? 3. So that is 0.3. In the same way, if I talk about what is the probability of sunny over no, so that is what? What is the total count of no? 4. And out of that, what is the value of sunny? 2. So it is 2 upon 4, that's 0.5. Agreed, everyone? Yeah.
Yes, sir.
Yes.
So we have now each and every probability. We will have each and every probability. So let's calculate. I'll be just calculating first for the probability of yes over sunny. So the probability of the yes over sunny, what is the probability of yes over sunny? So sunny over yes. What is the value of probability of sunny over yes? So it is 0.3 into what is the probability of yes? It is 0.7 upon. What is the probability of the sunny? So probability of sunny is what? 0.35? Please anyone solve it. Hmm?
0.612.
0.612, huh? So 0.612 is the probability of sunny. Let me calculate the probability of no. So again, for this, the probability of sunny over n. So what is the probability of sunny over n? 0.5 into, what is the probability of no? 0.28 upon the probability of sunny. So what is the probability of sunny? 0.35. Please solve it, everyone.
Point 407.
0.407. So it is easily visible that the probability of occurrence of yes is more than probability of occurrence of no. So henceforth, the classification or the prediction will be that the match will be played when the weather is sunny. Your model will predict, your model will classify that yes, the match will be played. Is that clear, everyone? So this is how your night base works. Any question? Friends, here you just see that we are using again this iris data, and let me show you this data all about. When I'm talking about this iris data, when you see we have four features, that is sepal length, sepal width, petal length, and petal width. And on the basis of that, we are finding out that what will be the species. Will it be setosa or versicolor or virginica? Yeah, this is you have to find out. Okay, next. So you know that here, if I ask you, do you think that the ID number will have any statistical significance to determine species? Do you agree, everyone, that this ID will have any statistical significance to determine species? It is just like your roll number will determine that whether you'll top or not.
No, sir.
Yeah. So that means this ID will not have any statistical significance. So here the column is starting from the index number 1, 2, 3, 4. These are the 4 columns which are important for as an input variable, and this is my output variable. So I just segregated this X and Y. You see, I took this I log, and out of that, I just took 1 to 4 column for the input, and the Y I took for the output. And you see, in this X, we have all this one. Next. Then we are just splitting our data into train and test. And since, okay, I tell you one thing. Whenever you will have less data, then always try to give more data to your training. Instead, because the more your model will practice, the more your model will see, the more it will do some conclusion. So here, this is the train and test. So according to me, what is my opinion? Instead of this 40%, you should give it 20%. 20% should be given to the test and 80% should be given to the train. Here, we are doing prediction, and for that purpose, we are calling this Gaussian I-base. So from skn base, we are importing this Gaussian NB. And then through this, we are training the model on the train data. So in this GNB variable, we just build our model, and then through GNB, we are training on the train data through fit function. After that, you see, we are just testing the model on the tested data. See? So this is my print. Okay. Now, let me see the accuracy underscore score. So the accuracy underscore score is what? 96.67. This is my accuracy underscore score. If I talk about on the train data, what is my accuracy underscore score? It is 95%. See, why this is coming? So even always we try to have the test accuracy more, but even if there will be 1 or 2% difference, even the 2 or 3% difference, so it will not matter. So here what is happening? We have this train and test data, and its accuracy is 96 and 95%. Okay, so my dear friends, in this way, we used to work on the naive base. Any question? All right then. So basically, this is the naive base that I had to cover. And now onwards, because I have to split my team, participant. So yeah, we'll just stop here, and we'll share this naive base related codes and all into the group. And then after, whatever we'll be discussing, it will be AI based or the ML based. Okay, everyone. So
सर
yes, Sumit.
सर एक बार सीसी अंडरस्कोर अल्फा को एक बार दोबारा एक्सप्लेन करिएगा सर थोड़ा सा
कौन सा
कंफ्यूजन है सीसी अंडरस्कोर अल्फा सर वो सीसी अल्फा वाला जो कहीं आ रहा है सीसीपी अल्फा वाला
ओके
सीसीपी अंडरस्कोर
मैं समझ गया you're talking about postponing यही है ना
हाँ सर
okay see सुमित क्या सुमित नाम है ना
हाँ सर
सुमित मैं तुम्हें सजेस्ट करूंगा एक बार ना आप L1 एंड L2 रेगुलराइजेशन पढ़ना you just refer this L1 and L2 regularization. Actually, according to that also, we had done postponing. So what is this postponing? Postponing is also a regularization technique.
Yes, sir.
And when I'm talking about this regularization technique, that means what? Somewhere, I had a gap in your train accuracy and the test accuracy. Test accuracy is lying here while your train accuracy is lying here, while your test accuracy is lying here. So there's a gap, there's a gap. So, whenever we say that our model is the right fitted model, then always there should be the train accuracy high, the test accuracy high, and there should be no gap. Means, although it is not possible, but they should be very close to each other. They should be very close to each other. Yeah. So whenever you'll have right fit overfitted model, then there's a term called as alpha. This alpha is what? It is the penalty term. It is the penalty term, and this penalty term is actually used to penalize your model. This is used to penalize your model, and just because of that, what exactly this alpha do? It reduce the magnitude. It reduced the magnitude. Just because of that, what happens? Your train accuracy becomes low, and your test accuracy becomes increased. Okay. And in another terms, I will say that actually this alpha, that is the penalty term, it added some impurity in your model. Just because of this impurity, what happens? Your train accuracy got decreased and your test accuracy will increase. Adding impurity means what? Suppose you have some bigger value of the magnitude. So when you'll be adding impurity, so obviously if your bigger value is in the positive, so this impurity will be negative. And whenever you'll be adding any negative number to a positive number, what will happen? That positive number will reduce from it?
Yes, sir.
Isn't? So in that way we work. If you want to go into detail, then you have to see the mathematical derivation. I'm just trying to explain you in short. So basically this alpha is there, which will have some penalty term that will be added to the model, which will reduce the magnitude of your model. Just because of that, what will happen? Your train accuracy will go down and your test accuracy will got increased. So what will happen? Although your train accuracy was up to 98 or 100%, so it has got reduced, and this test accuracy will increase. And what is your aim now? You just have to choose the alpha, that alpha at which your train accuracy is very high, the test accuracy also very high, and the second thing is that they are very close to each other. So suppose, and that's why if you remember yesterday when I was talking about the accuracy, I had given two options. One, where the training accuracy is 98% and the test accuracy is 92%, for instance. Another is where the train accuracy is 95.2% and the test accuracy is 93.8%. So Sumit, which model you will be choosing, this one or this one?
The latter one, sir.
Second one, no? Why?
Sir.
Because see, both are very good accuracy. Although one is having 98%, but it does not mean that 95% has becomes very less. You cannot say. So that is why when I choose this one, so the difference between them is what? Nearly 1.5 or 1.6%. But if I say here, so it is around 6%. Yeah, so that is why what has happened, we have tried with the multiple value of alpha. We have tried multiple value of alpha, and whichever was giving us the best result, we finalized them. And your model was built on the basis of that particular value of alpha. That was the thing. Even I show you one more thing, you see. Although that is not the part of your curriculum, to be very frank. You see, for example, we had built this, forget about each and everything. We have built this ridge regression, linear regression. Okay. In the linear regression, we are getting some little bit less error, sorry, accuracy. Forget about that. Here, please try to understand. We are building this ridge regression. It is also the regularization technique. So obviously there will be option of alpha. So here we, I don't remember the equation. I think, guys, if you remember, then please correct me if I will be wrong. So in the case of ridge regression, the equation is y minus beta I plus alpha into beta I whole square. Square means when it comes to lasso, that is y minus beta I plus alpha into beta I. I think this is there, no? I don't remember, but just forget about it. So what I'm saying that here we are trying with the multiple value of alpha, Sumit, in the parameters. We
Yes,
will
sir.
have multiple value of alpha. Now what we will do, we'll just add all the value of alpha. We'll just add all the value of alpha, and then we'll be trying to find out that which alpha is giving us the best result. Yeah. So when we applied this, then we found that the 100 is the best alpha value, which is giving the best score. Okay. In the same way, so you see, we have tried with the multiple value, 1, 1, this one. These were the values, but out of that, this alpha equals to 100 was giving the best result. And even you will try, then you will find out. Let me show you by running it only. Okay. Now you see here, even after 100, what is happening? Say I'm just giving here 105. And if I run this, you see, even though I have given 105, it's still, what is the best score we are getting? Same. Even if I'll be mentioning here 120, and I'm trying this, still you see, it is giving me the same. And that's why we just finalized this 100. So there will be certain parameter. After that, if you'll be getting the constant best score, then you should use the first where you are getting first time this score. Okay. So I hope now it is clear, Sumit.
Yes, sir.
Yeah. Any other question from anyone?
Sir, I have one question from KLM.
Who is this guy? Aman. Yeah, please ask.
Right. So the graph that we plotted between the train accuracy and test accuracy, what to conclude from that graph? I want.
Actually, if you remember that PPT, there I had mentioned that when you will be increasing the value of K, you'll be getting the higher accuracy in the train and the test. Okay. And when you'll keep increasing the value of K, what will happen? After a certain moment, your train accuracy will continue to increase, but your test accuracy will start decreasing. And what happens, dear Arpit, when the train accuracy will be very high and the test accuracy is low? What happens when the training accuracy is very high and the test accuracy is low? What is the meaning of this?
Overfitted.
Overfitted. So when, and you know that this case, the regularization term means we'll have to do tuning of it. We'll just have to find out that at what value of K our train accuracy and test accuracy both are high, because until unless both are not high, it is wasteless. So the first requirement is that your train accuracy and the test accuracy both should be very high. And after that, what is the second requirement? That they should be very close to each other. So what we will see, we'll just try to see that value of K at which they are very high and they are very close to each other. So this is why we are trying, we are just, making that plot with the multiple value of k, and then we are trying to see at what value of k we are getting the right fitted model.
Okay, sir.
Okay, Arpit, even I show you this plot again. You see, okay. Now, see. Okay, let me take a screenshot of it. So, Arpit, see, we had started with the k equals to 3. If you remember.
Yes, sir.
So, this was somewhere value of k equals to 3. Then you had 6, sorry, 5. Then you had 7. Then you had 9. Yeah. So even if I see here that this is the point where the train and test accuracy are very high as well as they are very close to each other. Yeah. And this is the point where they are very close to each other. Now, if I talk about this, then I can think that it will be somewhere very near to 10, that is k equals to 9. Yeah. If it will be starting from 3, 0, then 3, then near to 10, there will be 9. Isn't? So at k equals to 9, what is there? So the train accuracy is somewhere. This one, Arpit, I think that will be somewhere 97.8.
Yes, sir.
And this will be, I think that will be somewhere 97.3, if I'm not. Am I audible?
Yes, sir.
Yeah. So is that clear, Arpit?
Yes.
Okay, then we'll stop here. And
Sir, I have one more question.
yeah, please.
Sir, how do we know that y is continuous or discrete, that y we are getting in the output?
Okay. Sumit, whenever you will have number and multiple different number, first thing. Second thing, you can represent that number into decimal also. Then that will be what? Continuous. For example, weight of a person, age of a person, temperature, profit. तो प्रॉफिट में ये भी कह सकता हूं ना कि 50 रुपए या 50 रुपए 25 पैसे 50.25 कह सकता हूं ना.
हाँ सर.
तो ये सारे क्या हुए?
कॉन्टिन्यूअस.
अब एक बात बताओ, पूरे डेटा में मेरे पास कोई नंबर ऑफ डिजिट्स हैं, कितने डिजिट हो सकते हैं टोटल?
10 डिजिट.
10 डिजिट. तो टोटल कैटेगरी कितनी हुई? 10 0 to 9.
Yes,
अब अगर मेरे पास मान लो 1000 डेटा है, उस पूरे 1000 में कुल मिला के यूनिक कितनी वैल्यूज होंगी? लिमिटेड.
यस सर.
है ना? तो ये क्या हुआ? डिस्क्रीट हुआ. तो whenever we'll have data and it will have very very countable unique values. So that is what? That is discrete. If you will have the number and it will be on the basis of infinite range. क्या मैं कह सकता हूं कि अगर वेट होगा तो वेट की वैल्यू 20 या 25 या 22 हो सकती है? क्या मैं ऐसा कह सकता हूं?
वो तो पॉइंट में भी जा सकता है.
आए समझ में? तो अगर कोई नंबर पॉइंट में भी जा सकता है तो क्या कहलाएगा?
कॉन्टिन्यूस।
और जिसको जिसको हम डेसिमल में रिप्रेजेंट करें और उसका कोई मतलब नहीं बैठता, वो क्या कहलाएगा? आइए समझ में?
हाँ सर।
ठीक है, ओके। और कोई क्वेश्चन? एनी क्वेश्चन फ्रॉम एनीवन? All right then. So thank you everyone. Thank you so much. Bye bye. Take care. Happy Sunday.